Today the lesson is very light. It's quite light today. Today we are going to do a revision on the probability chapter. Okay, because this chapter seems to can be quite new for all of you. And then there are a few formula involved as well. So this lesson is to prepare you to go for your test one on this coming Monday. Okay, so after we discuss the probability chapter, then we can also briefly go through the statistics chapter. Okay, then we can also discuss on the issue that you want to ask on test one on this coming Monday. Okay, so we should be able to finish this lesson within 1 hour 30 minutes. Okay, we should be able to finish before 4 o'clock. Okay, so let us start now. So for the probability chapter, okay, what are the things that you need to know? Let me share the screen now. All right. So okay, so at first you have to know what is the meaning of probability. Probability means chance of an event happens. Okay, chance of an event happens, or chance of phenomenon or activity or observation happen. Okay, so you can use P or PR to represent probability. Okay, so if you want to calculate probability of event A happen, then what is the formula that you can use? Okay, in fact, you can use the relative frequency rule formula in order to calculate the probability of event A. Okay, so what is the formula? Formula is equal to NA divided by NS. Okay, so NA is referred to number of elements from event A. Okay, the possible outcomes from event A divided by number of elements in the overall sample. Okay, in your overall space of sample, and we call as NS. Okay, so NA divided by NS, you may find that the value that you get right is always between 0 to 1. This is the way you check your answer. Probability value cannot be negative number. Okay, cannot be negative number. The probability value. Okay, and the probability value also cannot greater than 1. This is the way you check your answer. We call this as the value range rule. Right? So the probability A can be equal to 0 exactly, can be equal to 1 exactly. So if probability A is equal to 0, that means event A confirm is not going to happen. Okay, guarantee A is not going to happen if PA is equal to 0. If PA is equal to 1 exactly, that means 100% event A is going to happen. Okay, so make sure that you have to remember this value range rule. Okay, so these are the basic formula that you need to know, okay, in order to answer the question that probably involve only one event. So far so good. I stop for a while. Any question on these two? These are the basic one. You need to know. Maybe you got question to ask you also to test your understanding. Among these 4 values, which one is not be the possible probability value? Something like the practice exercise question. So get ready this. Test understanding on this rule as well. Okay, so far so good. So far okay. All right. So because of this, so that means probability A plus probability non A are always equal to 1. Okay. This A bar means non A. Okay. Complement of event A. This one is called as complement of event A probability, or non-A, right? So probability A plus probability non-A always equal to 1. Probability A plus probability non-A is equal to 1, always equal to 1, conform, right? So if, let's say, if you're asked to calculate probability non-A, okay, sometimes you may ask to calculate probability non-A. Then you can use this formula by transposing the formula by putting non-A, probability non-A as the subject, right? So in fact, we can change or transposing the formula. So I'll show you. Okay, so based on this complement rule formula, if you want to calculate probability of non-A, it's easy only, right? You just need to transpose the formula. Okay. So okay, so we can create probability of non-A equal to 1 minus probability of event A. So this formula, in fact, is derived from the complement rule formula. So can you understand this formula in order to get the probability of non-A? Yeah? So far, so good. You just need to move this one, the PA, move to the right-hand side becomes minus. Okay. Let's stop for a while. Are you okay with complement rule? So similarly, also, if you want to calculate probability non-B, okay, probability non-B, then the formula should be 1 minus probability of event B. Yeah. 1 minus PB in order to get probability of non-B. That's the meaning. So we can just flexibly try to apply this formula. I stop for a while. Any question on this? Complement rule? Okay, you can use the Venn diagram to show the relationship between A and non-A. Venn diagram. I use a Venn diagram to show the relationship. Right, this one. So if this circle is A, area A, and if this square box is referred to the size, this is the sample space. Let's say this is the sample space, the S. All right. So that means the non-A should be this part. Okay, outside the circle, but it's within the square. Right. So it's the orange color part, orange area. So the area of A plus the area of non-A always equal to 1. Okay, which is equal to the S. Okay. So far, any question on this? Okay, all right. Then the next formula is union rule. Okay, union rule. Union rule. Okay, so what is the meaning of union here? Union, we use the U to represent something like U. Okay, to represent union. Okay, sometimes we use the word union. I put here. All right. Union statistics means all. Okay, is it means all all. Right. All right. And we use the U symbol to represent union. Okay. U symbol to represent union. Maybe I can put a symbol of U. We use U symbol. Okay. This one. Okay. It means all, all. All right. So what is the formula to calculate probability of A union B? A union B, A union B means it can be A or B, okay, or both. That's the meaning. Okay, I repeat. A union B means equal to probability A or probability B or probability of A intersect B. That's the meaning. Okay, or both lah, right? It can be probability A plus probability B, and then add the property of A intersect B in fact. Okay, but if you see the Venn diagram, you may find that the area of A intersect B overlap 2 times here. I'll show you the Venn diagram. Okay. So A union B, it actually is the whole yellow area. Okay, the whole yellow area. But you may find that the intersection area, this part, okay, is overlap. Right, is overlap. That means if we add these 2 times, that means we double calculate the probability. Okay, as a result, we need to minus this area for 1 time in order to avoid the double counting. Okay, so A union B means is probability A plus probability B, and then minus the probability of A intersect B. Okay, so this formula in fact is derived from this diagram. Okay, so you need to remember this formula, very important. So in the quiz, okay, if you've forgotten, what can you do is you can just refer to the lecture notes, or maybe you can make your own summary, so that you can recall the union rule formula. Okay. So this is the formula, yeah, to apply if the question is involving union question. This is the formula that you can apply. All right. And some students may ask, then can this union formula applicable to dependent, independent, or mutually exclusive? Yes, can. All right. A union B formula, this formula is applicable to either mutually exclusive, independent event, and also dependent event. But okay, but right, be careful with this part, the A intersect B, this part. Okay, the A intersect B, this part, right? This one, this term, is depends on the relationship between A and B, whether it's mutually exclusive, independent, or dependent. Okay, A and B should be easy to find. For these two terms are easy to find. Only this one. Okay, but union rule formula is applicable to all of the mutually exclusive, independent, and dependent events. So later on, I'm going to discuss with you what is the difference, okay, among these. But we're still using the same formula to calculate the probability of A union B. Yeah, this is the only formula. Okay, the difference is only this one. This one is slightly different. So later on, I'm going to explain to you what is the difference. Okay, only this part is difference. But anyway, the answer that you get for A union B probability always between 0 to 1. And this is the way you check your answer. All right, it's always between 0 to 1 for all of the probability question. Okay, so this formula is quite long. You may need to remember this formula, or you can try to copy down the formula, make your own summary. Okay, so that you can refer during your quiz or test or final exam. Okay, so this is this formula. You can use the Venn diagram, okay, to try to understand how does this formula been derived. It's from here, from this diagram. So far so good, All right. Then now I'll move on to the next type of event that show the relationship between event A and event B. Okay. All right. The next event is called as mutually exclusive. Mutually exclusive, what is the meaning? That means two events will not happen at the same time. Okay. Mutually exclusive events means the events will not happen at the same time, or happen simultaneously, or happen at once. That means two things cannot happen together or at the same time. Okay. So because of this, that means that the chance to have A intersect B will be equal to 0. This is the main characteristics of mutually exclusive. So that means A and B will not overlap for the mutually exclusive event. A intersect B is always equal to 0. That means A and B will not overlap, just like this. If I draw the Venn diagram, you may find that your Venn diagram will be something like this. Two circles will never meet each other. Okay, elements in event A and elements in event B are totally different things. Okay, and A and B will never overlap or meet each other. Okay, so in real life, what are the examples of mutually exclusive event? It can be swimming and taking mathematics test. These two events probably cannot happen at the same time, right? Anybody can swim and then meanwhile sitting for mathematics test. I think it's cannot, right? Because mathematics test is required to do some calculation. So may not be possible, right? These two events cannot happen at the same time. So if it cannot happen at the same time, then we can consider swimming and taking mathematics tests are considered as mutually exclusive events. If that's the case, probability of both events, the intersect event will be equal to 0, right? But however, when you are asked to calculate A union B, for the mutually exclusive event question, let's say, if you want to calculate A union B for the mutually exclusive event question, then what you can do is you still can use the formula that we learned just now, right? This formula is just like this part. For this part, the A intersect B is always equal to 0. You can list down the formula, no problem. You can list down whole formula for mutually exclusive event question if you want to apply this formula, right? But bear in mind, probability A intercept B is always equal to 0. This only happens when A and B are mutually exclusive. Okay, I stop for a while. Any question on this? Especially this part. Okay. So that means this one will be equal to 0 for mutually exclusive. So in short, A union B will be equal to A plus B only for the mutually exclusive question. Okay. But usually, I will just remember this formula enough. Okay, because when I apply to A union B, I know that okay, A intercept B always equal to 0 for mutually exclusive. Okay, any question on mutually exclusive? Another it can maybe student under 18 years old and right to vote during the upcoming election. These two events are also mutually exclusive because if a student is below than 18 years old have no right to go for voting. So these two events cannot happen at the same time. Okay. Okay, I stop for a while. Any question on mutually exclusive that you'd like to ask or anything you're confused? Okay, if not, then we move on to next one will be we go for the independent events. Independent events. Independent events means occurrence of event A is not going to affect the probability of another event happen. Okay, and vice versa. If A and B are independent events, that means event A is not going to affect chance of event B happens. Similarly, event B also will not affect the chance of event A occurs. Then this is called as independent events. Right. So for independent events, what are the main characteristics? For independent events, A intercept B is equal to probability A multiply probability B. This is the main characteristics of independent events. The main characteristics. Okay. So the formula is probability A multiply probability B for A intercept B equation. All right. So how are the examples of independent events? Example would be throwing one coin and throwing one dice. These two are independent events. Or throwing two coins or throwing two dice. Okay. Or choosing two balls one by one with replacement. Okay, with replacement. This type of question is also considered as independent events. Choosing two balls one by one with replacement. That means after choosing first ball, return the ball inside the box before choosing the second ball from the box. Okay. After choosing the second ball, drop down the color and then return the second ball inside the box. These type of events are considered as independent events. So if you see this type of question, then you apply this formula. Okay. So probability A intercept B is equal to probability A multiply B. Because A is not affected by B, B also not affected by A. So let's say if the question asking you to calculate probability A given that B already happened, then what is the answer? Answer is still equal to probability A. Okay, it's still equal to A. Why? Because A is not affected by B for independent event question. Okay. Similarly, also, if you are asked to calculate probability B, given that A already happened, then what is the value? Answer is still equal to probability B. Okay. Because B is not affected by A, even though we know that A already happened. Okay. So this formula only applicable for independent events question, right? Okay, because A intercept B is equal to this formula, right, for the independent event. So that means that when you want to calculate the, let's say, your A union B for independent events, let's say one question probably you may need to relate to A union B. Then what is the formula? Oh, it's still using the same formula. It's still A plus probability B minus A union B. It's just like for independent events, your A intercept B now is equal to A multiply B. So you just need to substitute minus brackets, probability A multiply probability B. Then you put to here as the probability of A intercept B. Okay. So you may find, you see the difference between mutually exclusive and independent events. For mutually exclusive, A intercept B is 0. For independent events, A intercept B is equal to probability A multiplied probability B. Okay, can you see the difference between the mutually exclusive and independent events? I stop for a while. Okay, so because of this, you may have found that when you want to calculate the A union B, this term will be slightly different. Okay, for these two different types of events. I stop for a while. Any other question that you would like to ask? So far, so good. Okay, yeah. So bear in mind, okay, when you see, okay, the question is like throwing 2 dice, or throwing 3 coins, throwing one coin and 1 dice, throwing 4 dice, okay, and also choosing 2 balls 1 by 1 with replacement. This type of question that means that you need to apply this formula, independent events formula. Okay. Any question? If not, then I'll move on to the last one. Dependent events.
No question, sir.
No question. Okay, good. Thank you. Thank you for response. Okay, so last one is dependent events. So A and B are dependent events if event A will affect the chance of event B happens, and event B also will affect the chance of event A occurs. Then we can conclude A and B are dependent. Okay, A and B are dependent. Then what are the major characteristics of dependent events? Because A and B are influence each other. All right, so we may need to apply the conditional probability formula. Okay, we need to apply the conditional probability formula for the dependent events question. Okay, so let's say, okay, if you're asked to calculate probability A, given that B already happened, and then what is the formula? Formula is equal to probability A intercept B divided by probability B. Okay, so we always use the denominator here. It should be the event that you put at the back. All right, that already happened. So we have to put at the denominator. Okay. So if the back is B, that means the denominator should be B as well. Okay. So similarly, also if you're asked to calculate probability B given A, if A and B are depend each other, then what you can do is you can modify the formula from here. All right. So that means it's B intercept A divided by A, because now A, we know that it's already happened. So that means we have to put A as the denominator. So bear in mind, A intercept B is the same meaning as B intercept A. Same meaning. This numerator and this numerator are the same number. However, A intercept A given B is not always equal to B given A. These two are different meaning. Okay, only the numerator are the same, right? But A given B is different from B given A. Okay, and based on this formula, actually you can try to transpose the formula to calculate the A intercept B, A intercept B for the dependent event question by using this formula that you learn. Okay, so let's say now, okay, so we can try to use this formula to calculate the value of A intercept B. Okay, so I try to copy this formula so that we can transpose the formula. All right. Okay, let's say now you want to calculate A intercept B. I try to use formula, all right? Intercept is N, like this. Okay. I use other color so that you can see. Let's say I use red color. All right. Okay, so let's say now we want to get the A intercept B for the dependent events question. Okay, so what can you do is you have to transpose the formula by moving probability B to the left hand side becomes multiply with probability A given B lah. Right? So the formula should be equal to probability of A given B. Okay, I use longer so that you can see this. It should be A given B. A given B. Okay. Multiply, I can use this symbol, okay? Or you can use dot symbol also, okay? Dot symbol, with probability B in this case, okay? Just transpose formula from this one in order to get A intercept B, using this formula, okay? So I try to reduce the sign so that we can have some space. Okay, so similarly also, A intercept B, besides using this formula to calculate the A intercept B, you can also use this formula to get A intercept B, right? The last formula. This formula also can be used to calculate A intercept B as well, okay? So if you use this formula, this one I move here for a while, Okay, so if you use the second formula, let's say, in order to get A intercept B, then it's easy only. Okay, so I put here one more. So you can transpose the formula. So this one I can use purple color, I use purple color. Okay. So in fact, B intercept A same meaning as A intercept B, same meaning, all right. So in order to get B intercept A or A intercept B, what you can do is you can transpose the formula by bringing probability A to the left hand side, becomes multiply lah, right? So answer is equal to probability B given A multiply probability A, right? So this formula, the purple one, is derived from here. Okay, the red one is derived from this one. Okay? So we use this formula when A and B are dependent events. Okay, so usually how to solve the dependent events question? You can use the tree diagram, or you can use the joint probability table in order to solve the question that involve dependent events. So very important, all right? So very important if you see the question involve tree diagram and also the joint probability table, something like this. Okay, so this joint probability table can be used also to calculate the probability for only one event, like this. You ask to calculate, let's say, probability A, only one event. Also, you can also using the joint probability table to solve the problem. Okay, like for instance, this question, probability A is refer to the employee who is under 30 years old. So now, if you choose one employee, okay, from the company, so what is the probability? The company's age is under 30 years old. Okay, under 30 years old is under this category. So in total, 35 of them. So this is the NA, no? All right. And in total, how many employees in the organization without consider their any differences? In total, altogether 100 of them. So this is the NS, number of sample available, okay, in your survey. So this is your numerator, this is your denominator. Okay, simplify, you get 0.35. Right. This one is calculate the probability B, right? Then next is to calculate the A and B. A and B means A intercept B, A intercept B. So actually, because these two events are the age and also salary are two dependent events. Age and salary in fact are dependent events. So if you use a joint probability table, it's easy, A intercept B. Okay, So the numerator should be the cell whereby these two elements intersect. That will be, okay, below 30SO is the event A. Yeah? Similarly, below than 25,000 is event B. Lah. So you go to check, okay, which cell intersect that have these two characteristics. Answer is 32. So 32 is the numerator. Lah. Denominator is the this one. Okay, is the NS. This one 32 actually is NA intersect B. Yeah? A N. Okay. Bracket A intersect B. Then you'll get 32, which is this one. Okay. Next is A or B. Or means union. If you see the word or, means union. Union, that means you have to use this formula. Okay, just now, this one. Okay, so this formula is applicable for all of the events, either mutually exclusive, independent, dependent events, or apply this formula. The difference is only this part. Only the A intersect B is slightly different. Okay, for mutually exclusive, A intersect B is 0. For independent events, A intersect B is A multiplied B. For dependent events, depends on the relationship. So A intersect B can be either this or this. Okay? This or this. In order to get the A intersect B for dependent events. Then once you have this one, you substitute to here for the even for the dependent event question in order to get A union B. Okay. So maybe you can try one question. A union B question. Let us see. Or this. All right. Or. So we know that, okay, we can copy the formula. Or means union. So copy the formula first. All right. Copy the formula, which is probability A plus probability B, then minus A intersect B. All right. Then, in fact, these three terms we already have the answer, obtain the answer already. For part A, B, C, that's not already obtain the answer. That's not for probability A is referred to probability of choosing one employee who is below than 30 years old. So we already have the answer just not in part A. So you copy 35 over 100. So probability B means the chance to choose an employee who has salary below than 25,000. Okay, so it's 43 over 100 substituted here. Okay, so the answer is from part B just now. Okay, A intersect B means number of employees who, okay, or you can say the probability, okay, probability of employees whereby the chosen employee has salary less than 25,000 and also have age below than 30. So you can go to the intersection cell between this row and this column, which is 32. Yeah, 32. This one, the intersection cell between this row and this column, 32. So substitute 32 to here. Okay, which is the N of A intersect B, and then 100 is NS. Okay, then you simplify, you'll get 0.46. So for if the table already presented in the in this format, then it's easy for you, right, to apply or to calculate the A union B when A and B are dependent event. Okay, you still can use this formula to calculate A union B. Okay, I stop for a while. Any question on A union B that can be applied to dependent events question? Okay, right. Next is A occurs. Given that B occurs, what is the meaning? You have to know the meaning so that you can change this sentence into a mathematical equation. Okay, so the keyword is here. Given. Given is the keyword. Given means this is the conditional equation. Conditional. Okay, and you may find that B is appear after this word, after given. So that means B you have to put at the back. Okay, given that B already happened. Okay, so that means you're asked to calculate property A given B. This is the meaning of the sentence. Okay, because A and B are dependent event, so that means you need to apply this formula that you already learned. Okay, you have to apply this formula. Okay, so A union A given B means A intersect B divided by probability B. So you copy this formula, okay, into here. This one just now. Okay, into here. All right. So now next step, what is the value of A intercept B? You already get the answer just now in part C, right? Which is 32 over 100. You already have the answer. 32 over 100 is A intercept B. Okay. This is the event A. This is the event B. Yeah. So 32 over 100 put here. In fact, this one, this one actually is 32 over 100. Okay. 32 over 100. Maybe I use some color. All right. 32. 32. Maybe I can use purple color. Okay, which is referred to this. Okay. 32 over 100. All right. Then this part divided by property B. Property B means the numbers of employees who have who have salary below than 25,000. Salary below than 25,000. You can refer to this, the instruction here. So 43 is the number of employees who have salary below than 25,000. So actually the probability of probability of B means 43 over 100. 43 over 100 because both numerator and denominator have 100, so 100 can be compensated. Okay, 100 can be compensated. So the answer is 32 over 43. Okay, so you may leave the answer in the fraction number, it's fine. Okay, you can leave the answer in the fraction number, or you may leave the answer in the decimal number as well. Okay. And probably can leave the answer in 3 to 4 decimal places. Okay, maximum 4 decimal places enough. Yeah? So that means 74.4% the chance this event will happen. A will happen given that B already happened. That's the meaning. Okay, 74.4% chance that event A will happen given that B already happened. Okay, so the last example, I think is also the conditional question. Okay, so now is you ask calculate property B given that A already happened. So the keyword is still given. This is the keyword. That means we need to apply the conditional formula. Okay, conditional formula. But because A and B are dependent, so we still have to continue using this formula. Because A and B for this question now are dependent. So we need to apply this formula. Okay. Then, okay, what should we do? Okay, so this question is calculate property B given that A happened. Okay, so you can use the formula of property B intersect A divided by property A. So that means it's apply this formula. Okay, apply this formula. This one, this formula. Okay. So the only difference is only the denominator. Property A is referred to the number of employees who have age below than 30 years old. So altogether 35 of them. So substitute to here 35 minutes from here. Okay. So get 91, 0.914. Okay. So next question is also conditional question because of this word given. This is also conditional question. Okay. So any question on joint probability table? Joint probability table. So far, okay? All right. So besides joint probability table, if the question is choosing two balls from the box one by one without replacement. Okay, if you see the word without replacement, then that means that this question is also involve dependent events. Okay, maybe we can go through one more time again. In fact, I already gone through one time with all of you during the last lesson. The question that involved the balls. Okay, let me see whether are here or not. Okay, I try to check. I think I saved in one of the. Let me unshare first. Okay. I try to find out from my data file. Maybe I think it's from the top. Let me see whether it's in the canvas. Go to canvas now. Canvas under the modules. Okay, I try to share the screen now. It's from the module week number 4. Yeah, this one. This question, without replacement. Okay. If you say this type of question, without replacement, that means choosing the first ball and choosing the second ball are dependent events, two dependent activities. Okay. If the question is set in this way. So let's try, okay, to solve the problem. Let's try. Okay. So now is, let's say, okay, there are 6 blue balls and 5 red balls in a box. So in total, 11 balls inside the box. In total, there are 11 balls inside the box. All right. If we don't count about the color, in total, there are 11 balls in a box. Okay. So that means NS is equal to 11. So I can say that NS is 11. Okay. I just put here, maybe put a footnote there. NS is 11. Okay, and among these, okay, 6 are blue balls. So that means NB, I can set NB lah. NB is equal to 6. And then there are 5 red balls. That means NR. I use R to represent red. So number of elements or number of balls or number of red balls. Number of red balls is equal to 5. Okay, so now it's 2 balls are randomly taken one by one without replacement. Okay, so now you're asked to calculate what is the property of choosing one blue and one red. One blue and one red. Okay, so this question, the problem is the challenge for this question is this does not inform whether the first ball is blue or red. It does not inform at all. So the first ball chosen can be blue or red. If the first ball is blue, that means the second ball should be red lah. All right. So it can be the first outcome. The first ball is blue, and the second ball is red. Okay. Or it can be the first ball is red and the second ball is blue. So this can be the second possible outcome. Okay. Any other possible outcome or combination in order to achieve this? No, no more. Only two possible combinations. Either this, the first term, or this term. Okay? Only two possible combinations. All right. So once you have decided, okay, the combination, then the next is to substitute the number into each term. Right? The number, the probability value into each term. Okay, so we solve this part first, the first term. So what is the probability? The first ball chosen is blue color. Answer is 6/11. All right. Because when we choose, we have the first drawn. In total, inside the box got 11 balls, right? And then there are 6 blue balls. So answer is 6/11 for B1. Okay, then multiply with the probability of B2. With the second drawn, with second withdrawn. Okay, let's say second withdrawn is the result is red color, red ball. Okay, so how is the probability to get the second ball is red color? Answer is 5/10. You may ask, what is the reason only 10? Because the first blue ball that we choose will not be returned inside the box before choosing the second ball. So as a result, you may find that for the second withdrawn, the total numbers of ball only consists of 10. Not 11 anymore, only 10. All right. Numerator is depends on the result. If the result is red, that means the total number of balls inside the box for during the second withdrawn is 5. So we substitute here. So be careful. Here now is only 10 for the second withdrawn. Okay. Okay. Now we'll move on to the next possible combination. It can be the first ball is red color. Okay, so how is the probability? The first ball is red color. Answer is 5/11. Right? 5/11 for the first withdrawn. Multiply with the probability. Second ball is blue color. Answer is 6/10. Why? Because when choosing the second ball, the total numbers of balls inside the box consists of only 10. So now the denominator for the second withdrawn only 10, not 11 anymore. Okay, so simplify this expression, you'll get 6/11. Okay, or you may just round the answer to 4 decimal places if you want. Okay, but this will create the rounding error. Or you may leave the answer in fraction number. Yeah, up to you. You can decide. So are you okay with part A? So far okay? Okay, then I'll move on to part C first. Part C. The part C is what is the probability of choosing 2 red balls? Because both balls have the similar color. Okay, both balls have the similar color. That means sequence is no longer important. Okay, so there is only one possible outcome. It can be first ball is red, second ball red. That's all. Only one possible outcome because both balls have the same color. Okay, so sequence is no longer important. So only one. We only should count one time only. Otherwise, it will be overlap. Okay. So only one possible outcome if 2 balls have the same color. Okay. So what is the probability? The first ball is red color. Answer is 5/11. Then the first ball chosen, the red color ball will not be returned inside the box. Then we choose again. Okay. Second ball, what is the probability to get red ball again? Answer is 4/10. Let's be fair. You'll get 2/11. Okay. So be careful with the word of the question. Have to be careful. Okay. Okay, then part B. At least one red, because we only choose 2 balls. So at least one of the ball must be red color. That is the meaning of the question. Okay, so at first you have to identify what are the possible outcomes. Okay, in order to meet this criterion, at least one ball. We choose only 2 balls. At least one of the balls must be red color, and that is the meaning. Okay, so the possible outcomes are, it can be first ball is blue, second ball is red, or the second outcome can be first ball is red color and second box is blue color. Or the third outcome can be first box is red and second box is red also. Okay, because if the box have the same color, we should only count one time. Okay, count as one possible outcome only. If two boxes have the same color, we only count one time, one possible outcome only for this part. Okay, so don't go to plus p r2 multiply r1. No, only count one time. Okay. If both boxes have the same color, right? Then we substitute the number in. So this part we already have the answer. The first term we already have the answer from here. Yeah, from here we already have the answer. And this one is from here, already have the answer. This one is from part C just now, already have the answer as well. Yeah? So simplify is equal to 8 over 11. Okay, let's stop for a while. Any question on this type of case? Okay, so if you see this type of case, make sure that you use this method to answer the question. You use this method. Just bear in mind the second ball, denominator has to deduct 1. Denominator has to deduct 1 for the second withdrawal. So far, okay? Let's stop for a while. Any question? No, Okay. So make sure that you know how to answer if this type of question come up. All right. What happens if the two boxes chosen are with replacement? If that's the case, then that means that these two withdrawal of boxes are considered as independent events. Okay. So I think I also already shown you one time the working last time using this. All right. So you might find that the case seems to be quite the same. Still the same, 6 blue balls and 5 red balls. But the way to return the ball will be slightly different. And this one is with replacement. That means after choosing the first ball, return the first ball before choosing the second ball. And then after choosing the second ball, return the second ball inside the box again. And that is the meaning of with replacement. Okay, so let's see the question. Same question. What is the property of choosing one blue and one red? Also the same. There will be two possible combination. Can be the first ball is blue, second ball is red, or first ball is red, second ball is blue. Okay, let's simplify. I'll try to substitute the number into each possible outcome of the probability. Okay. So for the first term, the first outcome, it can be the first ball is blue. So answer is 6 over 11. So return the first blue ball inside the box. Choose the second ball. What is the property? The second ball is red color. Answer is 5 over 11. Right? It's still 11. The denominator is because the first ball chosen already returned inside the box before choosing the second ball. That's why you may find that the probability for the second withdrawal, the denominator is still equal to 11. That's the meaning. Okay? So be careful with the question. You have to read the question properly. Okay? Whether it's with replacement or without replacement. So these are the things that I need to emphasize to you for the probability chapter. Okay, for the probability chapter. Any other questions that you would like to ask on this chapter? So you need to practice. One thing is you have to practice. Then you know if you see this type of question, then what method you want to use. Okay. I stop for a while. Okay, it's already 3 o'clock. So 1 hour gone. Any other question that you want me to discuss? Maybe from your tutorial or from your practice exercise 1 on the probability question? Okay. Maybe later on, I'm going to pause this and the summary later on. I try to tidy out the summary. Okay. And then I'll just combine this summary slide with the previous slides. Okay. This one, I'll try to arrange properly. Okay. All right. Then how about the statistics chapter? Graph, ungroup data measurements, and also the group data measurements. Are there any measurements that you want me to go through? Mean, mod, median, first quartile, third quartile, standard deviation, variance, range, interquartile range, and skewness, and also the coefficient of variation. Any question that you want me to go through? So be careful for group and ungroup data. The formula for calculating the measurement can be slightly different. Formula can be slightly different. So I try to open the chapter 1 summary. Okay. Okay, I go back to your canvas again. Okay, go to modules. I think the first 3 chapters summary should be under the week 3 lecture. Okay. Okay, this one, right? Okay. So if you want to calculate the mean value for ungrouped data, then you use this formula, total x divided by n. For group data, the mean is equal to total fx divided by total f. So that means when you want to calculate the mean value for group data, you need to prepare a few columns. You need to have the x column, the f column, and also the fx column. So that you can calculate the total value for total f and also total fx. Okay. So you need x, f, and fx column in order to get the total value for both. And this is the way you interpret the value for mean. Okay. So mean means average. Okay, mod means the most frequent occurs number of value or object. Okay. So if you want to calculate the mod value, it's better for you to sort the data, okay, from lowest to highest, so that you know which number or object appears the most. Then that will be the mod value. So sometimes there will be no mod. Sometimes can be more than one mod for a set of data. If the data are presented in the group format, either in the we call it as a single score frequency table or using the class interval frequency table, then you have to use this formula to calculate the mod value. Okay, so bear in mind, you must know, you must try to convert the classes, okay, into the boundary classes. So that means there is no gap. Okay, make sure that there is no gap in between the two classes before you want to apply this formula. We have to use the class boundary figures in order to calculate the mod value by using formula. So make sure that you know the meaning of triangle 1 and triangle 2. C is the class size. Okay, so it's using the upper boundary number minus the lower boundary number for each class. For the model class, upper boundary minus lower boundary of the model class. This L is the lower boundary of the model class. Okay, triangle 1 is the frequency difference between the mod class and a class before mod class. Okay, triangle 2 is the frequency difference between the mod class and a class after the mod class. So you may find that the triangle value for both are always positive number. Why? Because the frequency for mod class has the highest frequency. All right. So the triangle 1 and triangle 2 always positive. This is the way you check your answer. So far so good for mod. So this is the way you can elaborate the value of mod. Okay. Another method to estimate the mod is using the histogram, right? But sometimes may not be so as accurate. It's better to use formula. Okay. Okay. Median means the middle number. So that means it's Q2 or P50. So if the data are presented in the ungrouped data form, okay, Then the first step is you must sort the data first. Remember, to sort the data from lowest to highest first. Okay, sort the data. And then the next step is to identify the location of Q2. So for ungroup data, the location of Q2 is term of n plus 1 divided by 2. Okay, have to put plus 1 divided by 2. Okay, so identify the location, then lastly you can identify the value of Q2. Okay. So how about if the data are presented in the group format, then you have to identify the location of median using this formula. Okay, location is referred to the term. So it's total F divided by 2, no plus 1 anymore. You see the difference between ungroup and group data for the formula of location. Slightly different. So make sure that you can remember, or you can just refer to this slide. Okay. After you identify the location, then the next step is to apply the formula, use the formula, this formula, to calculate the median value. So make sure that if you want to use this formula, the classes must be in the boundary classes. That means there is no gap in between two classes. Make sure that there is no gap. Okay, so that you can apply this formula. So LM means the lower boundary of the median class. C is the class size. Okay, the formula is using the upper boundary minus the lower boundary value of the median class. Okay. This one, total F divided by 2, you may find that the answer should be the same as this one. Total F divided by 2 is about the same as this one. Okay. How about this? This is the total frequency before the median class. Okay, this one it should include all of the frequencies, all of the frequencies before the median class. Let's say before median class there are 3 classes, then you have to sum up all of the frequency for that 3 classes before the median class. Okay. How about this one? Let's say maybe, okay, I'll give you one example. I can go out a little. You can refer to the notes. Let's say this one, right? Like this. So this total F divided by 2, for this question, how many data altogether we have? This total frequency. Total frequency is equal to 25 only. Okay, we have 25 frequency. So what can we do is you substitute 25 to here, to the total F. Divided by 2, 2 is because it's half, 50%, means median. So that's why we divided by 2. So 25 divided by 2 is the value for this part. Right? This one, this term means the total frequency before the median class. All of the frequencies, okay, before the median class. So before the median class is these first 3 classes. Okay, so you have to sum up 6, 2, and 1, and substitute to here. Okay, 9. Okay, then how about the denominator? Denominator is referred to the frequency in the median class, for the median class. So median class is this class. So the frequency is 8. Substitute 8 to here. Okay. So some students may ask, how do we know the 4th class is the median class? Okay, it's here. You have to identify the location first. Okay, because from the location or the term, then you can identify the median class. Okay, let's say, okay, we start from the beginning again. Let's say, okay, we start from the location, identify the location or term of median using this formula. So it's at the location of 12.5. Location of 12.5, okay, is the location of median. That's the meaning. Okay, location of 12.5. Okay, so now we go back to here. Okay, we check. First class, the frequency is 1. So that means term 1, only term 1, the first term, the lowest number is in first class. Only the student with the lowest score is in this class. In this class, only 1 person only, which is term 1. Okay. Then second class only consists of two students who are from term 2 until term 3, right? Because of this frequency. So only 2 students are under this class, term 2 and term 3. Okay. Then the next class, the frequency is 6. Okay, so this class is for term 4 until term 9. How to get term 4? Term 4 is because after term 3 in this class, then the next term should be term 4, right? Follow the sequence. All right. And because this class has 6 frequency, all right. So what you can do is you can use 3 plus 6. 3 plus 6, you'll get 9. 3 plus 6, you get 9. So term 4 until term 9. That means those students who scored the lowest, the 4th lowest and the 9th lowest score are under the 3rd class. And that is the meaning. Okay. Then the next class is for term 10 until term 17. So you may find that term 12.5 is within term 10 and term 17. So we can conclude this class, okay, is a median class. So that means that the median value should be between 60 but less than 70. Yeah? The median value should be in between 60 and less than 70. That is the meaning. Okay. So how to get the exact value? You use this formula. Use this formula to help. So simplify, you get 64.4. So bear in mind, your answer should be between this class boundary. Okay, for the median. Then if the question asks you to interpret the meaning, then you can say 50% of the observed people, or in this case is students, have statistics score below 64.4, and another 50% of the students had statistics score above 64.4. Okay, so bear in mind, be careful whether the data given are group or ungrouped. Right. So T1 and T3 also the same. So T1 is also referred to first quartile, or we call it as lower quartile. And T3 is upper quartile or third quartile. Okay. So I'm not going to go too much again, because I believe the steps to calculate Q1 and Q3 are about the same as Q2. Okay, then for the dispersion measurements, okay, you must also know how to calculate the standard deviation as well, for ungrouped and also group data. So for the ungrouped data, we need to have X and also X squared. Okay, when you want to calculate the standard deviation for ungrouped data, you need to get ready the columns. Okay, so you need X column and also X squared column. Then you get the total value of X and also total value of X squared. Substitute the number into here. So bear in mind, the standard deviation always positive. As a result, the total X squared must greater than this part. Okay, greater than this term. If your answer is negative, then something wrong with your calculation. So you better check again. Okay. And this is for the group data formula. So for group data, in order to get the standard deviation, we need the X column, F column, Fx column, and Fx squared column. And so we need at least 4 columns in order to calculate the standard deviation for group data. Okay. So we use -1 formula is because the data, we assume all these data are sample data, not population. As a result, we use -1 formula, okay, for both the ungrouped and group data. This is the way you elaborate the value for standard deviation. Okay, let's stop for a while. Any question on standard deviation? So bear in mind, okay, you have to square root the whole result. Don't get excited. You have to square root the whole result in order to get standard deviation.
So
yes.
I have a question. How do we differentiate group data and ungrouped data?
Okay, all right. Okay, so I'll show you. I will go back to the question, right? To the practice exercise 1 question, in order to address your question. All right. Now we go to practice exercise. Okay, I use the student view. Okay, so still practice exercise I put under week 4 module. Okay, it should be week 4 module. Here. Okay, so we go to practice exercise 1. Okay, let's say question 3. Okay, there are two sets of data, right? So do you think, what do you think? Do you think these are ungrouped or group data? Anybody? What type of data? Ungrouped or group?
Ungrouped data.
Ungrouped data, huh? Because not in the table form, right? So that means
Yeah.
ungrouped. We have two sets of ungrouped data. Yeah? Ungrouped data. Okay, next.
Oh, okay.
How about this? Question 5.
Group data.
Why? Okay, group data. Yeah, correct. And then the data actually already being grouped into different classes based on frequency, based on the single score. Okay, based on the single score. So each class is assigned. Yeah, each we call it as the each observed. Okay, week is assigned with a number only, one number, single number. Okay, in each class. Okay. So there are how many classes altogether? 5 classes altogether. Okay, but each class we only allocate a number, right, for each class. So this type of data is called as single score frequency data. Okay, and this can be considered as a group data also. Okay, it's considered as group because we already classified all this frequency, yeah, based on classes. So this is also group data. Okay, but the special thing is each class is assigned with a number only, single number. Okay, next. This one. Question 6.
Ungrouped.
Group or group? Question 6. Anybody can help? So it's good that you ask the question. Yeah. Yeah, otherwise we use the wrong formula.
Group.
Yes.
Ungroup.
Ungroup, correct. Ungroup data, right? So question 6, you have to use ungroup data formula. Okay. Question 7. Question 7, eh?
Ungroup.
Ungroup, okay. All right. Question 8.
Ungroup.
Ungroup, okay. Question 9.
This is group data.
Group data, right? And then the classes already given in the interval form, and it's also very kind because there is no more gap in between two classes, so we can consider this as the boundary classes. Okay, no more gap. So that means you can immediately use the formula of mean, median, right, to calculate the numerical measurements directly. No need to adjust anymore. Yeah, from limit class to boundary class, because you may find that the upper value of the first class is similar to the lower class value in the second class. Okay? Lower number in the second class are the same as the upper number in the first class. Same, normal gap. So directly you can apply the formula. Okay. Question 10.
Group
Group
data.
Group.
Group.
Group
Yes.
data, correct. Group data. Then you can also apply directly the formula because no more gap in between two classes. This one same. These are probability question already, probability questions. If you see join probability table, that means I have to use the dependent event. But if probability A union B, then you may need to use the conditional probability concept to help you to apply. All right. So this is how you differentiate between the group and ungroup data. Okay, I leave now. Okay. And sometimes you may ask to calculate the range and interquartile range. Do you know the formula to get the range value? Range, R-A-N-G-E. Do you know what is the meaning of range? Anybody? Range, R-A-N-G-E. What is the formula to get the range value? If data set is given, how to get the range number? Anybody? R-A-N-G-E. Do you know what is the meaning? What is the formula? if you are asked to get the range value? Anybody? Formula. Range.
Quartile minus a quartile.
Pardon? Range, but RNGE. Range. RNGE. Any idea? Range. Just now the formula that you mentioned is using the third quartile minus first quartile, right? That one is called as interquartile range. I think we have one question right just now is on. Okay, I go back to student view. I think there is one question is looking for interquartile range, right? Okay. Any question are looking for IQR, interquartile range?
Question 7, sir.
7, okay. This one, interquartile range. So just now the formula is equal to, I think, yeah, what is the formula you used just now in order to calculate the interquartile range?
Third quartile minus first quartile.
Correct. Okay, so I write down the formula, Okay, all right. So I think I use Word, Okay, Microsoft Word. I try to increase the size of the screen so they can see. Okay, so we have interquartile range, right? So the short form means IQR, all right? So that means you're using the third quartile, right? Minus the first quartile value in order to get the interquartile range, all right? This is the formula. So that means in order to calculate IQR, you need to calculate the Q3 and also Q1, then get the difference, okay? Then how about if the question is looking for only range? So what is the formula? Range. Any idea? Formula for range. Okay, the formula is using the highest number from the same set of data. Okay, using the highest value minus the lowest value. Okay, that is the lowest number. Then you can get range, right? So for instance, just now the question. So I use this data set, right? So if you're asked to calculate range only, okay, so which one is the highest value? 308, right? 308 is the highest value from this data set. This number is the highest. Then which number is the lowest? 96, right? So if you are asked to calculate range only, so answer will be 308 minus 96 for range. If the question only looking for range, so answer is 308 minus 96. So far okay, the formula for range, Okay, then next measurement will be, let me try to go back to the Canvas side. Okay, and then I try to leave from the student view. We go to the module just now. Okay, then the next measurement will be coefficient of deviation, CV, coefficient of variation. It should be coefficient of variation. Okay. P-A-R-I-A-T-I-O-N. Okay, so if you ask to calculate the CV, that means your answer should be in percentage. Bear in mind, the answer for CV should be in percentage. Okay, so the higher the CV, the more disparate the data distribution. The lower the CV, the more consistent the data distribution. Okay? So how is the formula to calculate the CV? Answer is standard deviation divided by mean and then convert to 100%. Okay? Standard deviation divided by mean. Then convert to 100%. So usually we can use CV to compare two set of data. Okay? So the higher the CV, the more disparate or the more varied the data distribution. Okay? Are you okay with CV? Any question on CV? So the unit of CV is in percentage. The final answer for CV is in percentage. Okay, lastly, skewness. Skewness is used to identify the pattern of the data distribution, to identify the pattern of data distribution. Okay, you can use either this formula or this formula to calculate the skewness value. Okay, if the skewness value is 0 exactly, that means the data is symmetrically distributed. It's normal. Okay, so it's a bell shape. You may find that the data distribution is a bell shape. Okay, if the SKP is 0. If the SKP is greater than 0, that means the data distribution is skewed to the right or positively skewed. So that means that the tail of the data distribution is on the right hand side. Okay, the tail is on the right hand side. Let me see whether I have example or not. Like this. Okay, if you see this type of distribution, the tail is on the right, like this histogram. This we can conclude the data distribution is skewed to the right hand side. Okay. So what happens if the SKP is less than 0? That means it's negative number. Okay, there is no unit for SKP. SKP only tells us whether is the data distribution is symmetrical, distributed, or skewed to the right or skewed to the left. There is no unit for SKP. So if the SKP is less than 0, that means the data distribution is skewed to the left or negatively skewed. Okay, and how does the distribution of the data will be look like? Okay, I think I have given an example, right? I've given an example last time. Let me see whether can use any of the diagram to show you the example. This one, yeah, that's why it's very hard to look at this, whether it's skewed to the left or right. I think it's from another chapter. Do you want me to show you the example? The pattern with the data distribution that's skewed to the left-hand side. It should be from our week number 1. I think it's week 1. Week 1 data. Okay, week 1, we go back to module. Or we choose week 2. This one is on the right, the tail is on the right hand side, so skewed to the right. And this one, the tail is on the left. Okay, very obvious. So we can conclude the data distribution is skewed to the left. Okay, always look at the tail for the SKP question. Otherwise, we can use formula. Okay. All right. So these are the things that you need to know for statistics. Any other questions? Before we move on to test 1 format. Online test 1. Okay, so now I go to online test 1. Okay, so now I think I already made the instruction available. Okay, let me see. Test one. So on Monday, we are going to have test one from 10 to 11 o'clock. Okay, but because I understand that some of you may have some technical issue, you may start the quiz at maybe 10:20, let's say 10:20, and then it's still okay. You still can enjoy full 1 hour of attending the quiz if you start at 10:20. So that means the system will allow you to finish at 11:20. Okay. All right. But I already made the system whereby right only allow you to because this quiz one will be only open until 11:30. So if you really want to enjoy the full 1 hour, the latest time that you must start to attend the test is at 10:30. Okay, 10:30, because the system will automatic close or shut down at 11:30 sharp. Okay. So if you really want to enjoy 1 hour to attend the quiz, make sure that you start before 10:30. Okay, you still can start at 10:40 or 45. It's still okay because the system will allow you. Even you start at 11, the system also will allow you to go in. Okay, you still can go in at 11, but you can only use 30 minutes to attend the quiz, the test until 11:30. Then the system will stop you to continue. So it's quite dangerous, So better start early. All right, better start early. Okay, let me see. It's like this, Okay, so on Monday I'm going to make the quiz accessible. Like this. Okay, let me see whether now you can access if I change to student view. Something like this. Okay, like this. So on Monday, Monday, okay, at 10 o'clock or before 10 o'clock, you should get ready already. Before 10 o'clock, should get ready. Okay, you go to Canvas, then go to modules, right? Then you go to week 6 module, okay, and click on the online test one. Okay. Now you should be able to click, but you cannot see any question. Only see this only, some instruction, okay, but you cannot see anything. Okay, so the quiz is going to start at 10 o'clock, okay? And then actually it's for 60 minutes. So that means that if you start at 10, you'll finish at 11. Okay? And the system will auto close at 11:30. Okay? So some students may ask, okay, if we start at 10, are we allowed to finish at 11:30? No. The system will stop you at 11 sharp if you start at 10. Okay? That's the meaning. So the duration of the test is only 60 minutes. Okay? Consists of 20 questions. So you can read the instruction here now. So that is the meaning of this instruction. So I just provide 30 minutes extra for students to access the online test one. Okay. So during the quiz, if you got during the test, okay, if you got any technical problems, you can always contact me either through the Microsoft Teams. You can just send message to me, okay, through our Microsoft Teams link, right? This one, the meeting link, this. So you can just type lah. You have got problem or how, okay? So that I can respond to you, or you can just email me personally. Email me lah, okay? Or email me, okay? You got problem, then I can contact you lah, okay? I may call you or I just email you, show you the steps involved. If you got any problem. And okay, the format of the question will be the same as the practice exercise. So one question has 4 options for you to choose the best answer. Okay. So each question has 4 possible options for you to choose. And no need to show the workings at all. You do not need to show the workings. Okay. Just check or click the answer that you feel that is the most accurate answer. I think in the system you should be able to go back. Let me see whether you can go back also to answer the question. Okay, let me go to the practice exercise 1 just now under modules. Practice exercise 1. So the format should be something like this also. So you have these instructions, okay, to remind you to bring your calculator if you have, right? Maybe you can also get ready some piece of papers for you to do some calculation if you want, right? You can take out some papers, get ready, all right? Or else you can use Excel. It's up to you. You can use Excel also to do your calculation, but no need to submit your Excel calculation to me. Okay, no need. For your own calculation, you can also use Excel. You can use paper, write something. No need to submit. Okay. And I think when you answer the question, let's say if you want to go back to check your answer, let's say now you already finished, okay, answering the question, and then you want to check your answer also can. You can go back and check your answer one by one. You can go back by clicking to here, okay, to check your answer one by one again before you submit. Okay. So any question on the online test 1? So the weighting of online test 1 is 20%. So it's very high, very high weighting. 20% of your overall assessment mark in this semester for this unit. So it's quite high. So that means one question worth 1 mark. One question, 1 mark. Okay. So if no other questions, then maybe we can just call a day early. You can relax. For mathematics, you have to study consistently. Don't study last minute. Don't study until midnight, 12 o'clock. For mathematics, you cannot do like that. For mathematics, it's like you really have to be fresh. Okay, when you time the test, it must be fresh. Okay, so don't study last minute one. Don't want. You have to be calm when attempt the question, so that you can avoid careless mistakes. Okay, so study until maybe Sunday until afternoon, and then can relax already. Can cross the book, relax already. Okay. So any other questions before we call a day? I'll start. Okay, I'll try to stop recording. Since no question, I'll stop recording now. I'll pause the video for this session later on.